So let's work an example of using the kinematic equations, kind of going through that procedure step by step. So here's a good example here, slightly modified from a problem that I have in the lecture note PDF. So you have, let's say, a 1,500 kilogram car traveling at 30 meters per second, which is around like 60, 70 miles an hour, I think. The driver begins to brake 10 meters away from a red light. So how much force would the brakes have to apply to the car in order to stop it just before it reaches the red light? Okay. So step one, identify and sketch what is the initial state here, what is the final state here, what does this problem look like? Okay, so initially the car is, let's say, over here, and it's traveling, let's say, to the right at a velocity of 30 meters per second. So this is my initial state. And then it travels along for a while. And then at some later time, it's over here. And this is going to be my final state. And in the final state, I want the car to come to rest just before it gets to the red light. So that means over here, the car is going to be at rest. And the distance between these two is going to be my 10 meters. So the distance between where it is in the initial state and where it is in the final state is 10 meters. So I think I'm in pretty good shape here. It says that a constant force is applied to the car, so the acceleration should be constant between the initial and final states. So I think I'm in good shape. This is kind of the problem in visual form, first of all, so that I can wrap my head around it a little bit. Next step is make sure I know like which direction I'm going to call the positive direction and things like that. So I'm going to call right is the positive direction. Okay. Next step. Now I need to start looking for known kinematic variables. Okay, so let me reread the question again, this time with an eye for not just any old information, but specifically there are 5 kinematic variables: displacement, initial velocity, final velocity, acceleration, time. So I need those 5 things. I'm looking for 3 out of the 5, hopefully. So let's see, 1,500 kilogram car is traveling at 30 meters per second. That's clearly one of them. Is that the initial velocity or the final velocity? Well, that's the initial velocity. I already went through figuring out that that was the initial velocity. So that means the initial velocity is 30. Is it positive 30 or negative 30? I can see in my picture the 30 meters per second points in the positive direction. So that's going to be positive 30. Okay, let's keep reading. The driver begins to brake 10 meters from a red light. Sounds like 10 meters is going to be another one of my known pieces of information. That sounds like a displacement, but is my displacement positive 10 meters or negative 10 meters? Remember, displacement points from the initial state to the final state. So if, if I were to draw the displacement vector, it would go from the initial state to the final state like that. So the displacement vector points to the right, which means it's positive. So that's going to be positive 10 meters. Okay, there's 2. Okay, how much constant force must the brakes exert on the car in order to stop it just before it reaches the light? So the fact that I want it to stop, that tells me that my final velocity is 0 because it's going to come to rest at the end of this process. Don't forget, things that are 0 are also knowns. And sometimes things that are 0 especially, it might not actually have a number in the question. It might be kind of implicit in some way that that is 0. Okay, so I see that I have 3 knowns. I feel good about this problem. I'm pretty sure that whatever the situation is, I'm going to be able to solve this already without even thinking about any equations. I know that I'm on a good track here. Okay, so step 3 done. Step 4, what is my unknown that I'm solving for? Okay, so what I want is how much constant force has to be applied to the car. So force is not one of the kinematic variables, so that might confuse me for a second. But then I say to myself, wait a minute, F equals ma. So if I can find the acceleration, I can find the force. So that means my unknown is going to be the acceleration. Okay. I've got my 3 knowns. I've got my unknown. That gives me my 4 variables. By the way, as a side note, the variable that I don't care about in this problem is time. Time is the one that did not come up. Now, having all of that information organized, now I pull out my list of kinematic equations. Now I pull out my list of kinematic equations, and I choose one. So now it's obvious which one to choose, right? Now it's obvious. I don't even have to think about it. People act like this is the hard part of the problem. I don't even have to think about this part of the problem. Boom, it's that one. Because I know that I want the equation that doesn't have time in it. So I already know what I'm looking for. By the time I look at the list, it's that equation. VF squared equals VO squared plus 2A delta X. Okay, so let me go back here. So the equation I want was VF squared equals VO squared plus 2A delta X. And once again, a lot of students act like this is the hard part of the problem. This is the part of the problem where I switch my brain off, because at this point, I can just sit here and daydream, and I'm just copying numbers from one column to another column, because I already have everything organized on the left. I've got VF, that's 0, VO, that's 30, 2A, that's my unknown, delta X, that's 10. Okay, so that means A equals minus 30 square over 20, which is 30 square divide 20, 45. Okay, now it might surprise me a little bit. I got a negative acceleration. Did something go wrong here? No, actually, negative acceleration should have been what I was expecting, because the velocity points in the positive direction and the car is slowing down. So the acceleration should end up with the opposite sign of the velocity, which it did automatically. I didn't have to put that in myself. That's why the acceleration is negative here, because it's slowing down while it's moving in the positive direction. So I got my acceleration there. Last thing I need to do is plug this into F equals ma. So the force is, this is a 1,500 kilogram car times a minus 45 on acceleration. And that gave me negative, because the force is also in the negative direction, 67,500 newtons. And there's my answer.